All right, so in this slide we go on to consider the cost function minimization problem for logistic regression. In the last video, we got a cost function for logistic regression. So how do we go about minimizing this? In fact, we can use gradient descent, just like we did for linear regression. There are alternative methods as well. Some are more appropriate than others. And we'll see briefly how you can use these in practice using a toolkit such as scikit-learn. I would point out that some of these are really not appropriate. Know-their-mean is used when you have a function that doesn't even have derivatives. And Powell also. So you need to research into these different methods to discover which are appropriate. In fact, for logistic regression, gradient descent will work just fine. Now, the gradient descent equations don't change at all, because the only thing that's different now is a different value of j. So the different value of j is going to have a different derivative. So the actual equations are going to depend on the value of this derivative. Now this looks like a very forbidding mathematical expression, taking the derivative of j, where j involves the logarithm of h, and h involves this kind of stuff. But it turns out that the result is relatively simple. The derivative of j can be expressed very compactly in terms of the functions h that we've already defined. And this looks very similar to the expression we had with linear regression, doesn't it? You have the difference times the value of the feature. But the implementation is straightforward. You update each parameter according to this rule. You can think of this as updating the entire vector of parameters with the gradient of the cost function. So the algorithm appears to be identical. In fact, the only difference is plugging in this h here. So in your computer code, there's not that much difference. It's basically a plug-in of one expression for another. Now the other techniques that we talked about, tuning the learning rate and feature scaling, still apply in this case. And of course the implementation should be vectorized. You saw in the Jupyter Notebook for linear regression how much faster a vectorized implementation is than one that is not vectorized and uses a loop. Now, as I mentioned, there are other algorithms for optimization, and we'll take a quick look at how you would use SciPy, or in particular the optimized package in SciPy, to implement one of these optimization algorithms. You'll be using the minimize function within the optimized package of SciPy. Now for all these packages within SciPy, you can find documentation online within the SciPy manual, and you can also find code examples online. And this explains the different arguments in the minimize call. If we go back here, first we have our cost function. Then this theta, if you look at the documentation, the theta is the initial value of what you're trying to optimize. Then you have arguments. In this case, our function depends on x and y. Our function is a function of theta, but it depends on x and y. So I need to specify the arguments. Then you specify the method that method may have some parameters and some options. Now the method TNC, you would have to look up what this is. TNC requires a gradient function, which is the derivative of the cost function. And in our case, we do know the derivative. So we would also need to define this gradient function as a function of theta and define that in my program before I call minimize. Now these other options you can look up in the documentation what this means. Disk true means just it displays the options as it's going along. And then here we have print result.x. Result will be an optimized object. Result.x will be the actual parameter values for theta. Now you remember that our equations treat x0 just like any other feature. So the x must include the x0. I think this should be extra column of 1s instead of extra column of 0s. Right, now once you have the thetas, you use our same procedure as before for making predictions. Now looking at a code like this, you can get a general idea of how it works, but the devil's in the details. You have all these little options here. What do they mean? How do they work? So when you want to get down to specifics, ChatGPT can be helpful. It may not give you exactly the right code that you need, but it can make good suggestions. So for example, I asked this to ChatGPT. I want to use the minimize function in SciPy to minimize the function sum of y times f of tx plus g of tx for the vector variable t. You have to be clear to ChatGPT what are the variables that you're trying to optimize and what are the variables that are given. So here I said y is a given vector, x is a given matrix, f and g are given vector functions. Y, f, and g all have the same dimension. Now, you see this is not exactly my problem, but in fact I can cast my problem in this form. And you can see I have tried to be very specific. Now, if ChatGPT's answer is not specific enough, you can ask it for more detail and you can be more precise. So ChatGPT generated some quite reasonable code that I can fill in the blanks and try to make it work. Right? So that's one tool you can use to come up with code if you want to minimize something. So if the answer that ChatGPT gives doesn't quite fit with what you need, you can always ask for more detail. But certainly this is a valuable tool. Now there is a specific implementation of logistic regression in sklearn. So here's a code example for how you would use that. Right? You import the logistic regression function. Now this command creates a logistic regression classifier called CLF with these various options. And you can read up on these options, what they mean. You can probably simply use the default options. They're just fine. Now this is the classifier. All you have to do then is supply your data to the classifier and the sklearn will do the rest. So in this case, logistic regression is set up not to require the x0 feature. Now, once you've done the CLF fit, this has primed the CLF regressor but you can apply it to new data. You just do clf.predict on your new data. Very nice and convenient way of classifying. Okay, so this has been a short video, but we'll be moving on to a very different topic, multi-class classification. So we'll stop here and see you next video.